More than 2,000 years ago, Eratosthenes compared the position of the sun's rays in two locations to calculate the spherical size of the Earth with reasonable accuracy. Eratosthenes was born in the Greek colony, Cyrene, on what today is Libya. As a young man, he traveled to Athens to pursue his studies. He returned to Cyrene and made such a name for himself in scholarly endeavors, that the Greek ruler of Egypt brought him to Alexandria to tutor his son. When the chief librarian of the famous Library of Alexandria died in 236 BCE, Eratosthenes was appointed to the prominent position around the age of 40. A man of many talents, Eratosthenes was a librarian, geographer, mathematician, astronomer, historian, and poet. Most of Eratosthenes' writings have been lost, but other scholars reported his work and findings which were extensive. Eratosthenes may have been the first to use the word geography. He invented a system of longitude and latitude and made a map of the known world. He also designed a system for finding prime numbers, whole numbers that can only be divided by themselves or by the number 1. Eratosthenes was also the first to calculate the tilt of the Earth's axis, which he figured with remarkable accuracy. The finding was reported by Ptolemy. Eratosthenes also calculated the distance from the Earth to the Moon and to the Sun, but with less accuracy. Yet, his most lasting achievement was his remarkably accurate calculation of the Earth's circumference, the distance around a circle or sphere. He computed this by using simple geometry and trigonometry and by recognizing Earth as a sphere in space. Most Greek scholars by the time of Aristotle agreed that Earth was a sphere, but none knew how big it was. How did Greek scholars know the Earth was a sphere? They observed that ships disappeared over the horizon while their masts were still visible. They saw the curved shadow of the Earth on the Moon during lunar eclipses. And they noticed the changing positions of the stars in the sky. Eratosthenes heard about a famous well in the Egyptian city of Syene in Greek, and now known as Aswan, on the Nile River. At noon one day each year, the summer solstice between June 20th and June 22nd, the sun's rays shone straight down into the deep pit. They illuminated only the water at the bottom, not the sides of the well as on other days, proving that the sun was directly overhead. Syene was located very close to what we call the Tropic of Cancer, 23.5 degrees north, the northernmost latitude at which the sun is ever directly overhead at noon. Eratosthenes erected a pole in Alexandria, and on the summer solstice he observed that it cast a shadow, proving that the sun was not directly overhead but slightly south. Recognizing the curvature of the Earth and knowing the distance between the two cities enabled Eratosthenes to calculate the planet's circumference. Eratosthenes could measure the angle of the sun's rays off the vertical by dividing the length of the leg opposite the angle, the length of the shadow by the leg adjacent to the angle, the height of the pole. This gave him an angle of 7.12 degrees. He knew that the circumference of Earth constituted a circle of 360 degrees, so 7.12 or 7.2, to divide 360 evenly by 50 degrees would be about 1/50th of the circumference. He also knew the approximate distance between Alexandria and Syene, so he could set up this equation. Eratosthenes estimated the distance from Alexandria to Syene as 5,000 stadia, or about 500 miles or 800 kilometers. He made this estimation from the time it took walkers, who were trained to measure distances by taking regular strides, to trek between the cities. By solving the equation, he calculated a circumference of 250,000 stadia, or 25,000 miles or 40,000 kilometers. Several sources of error crept into Eratosthenes' calculations and our interpretation of them. For one thing, he was using as his unit of measure the Greek unit stadion, or the length of an athletic stadium. But not all stadiums were built the same length. In Greece a stadion equaled roughly 185 meters or 607 feet, while in Egypt the stadion was about 157.5 meters or 517 feet. We don't know which unit Eratosthenes used. If he used the Greek measure, his calculation would have been off by about 16%. If he used the Egyptian one, his error would have been less than 2% of the actual Earth's circumference of 24,860 miles or 40,008 kilometers.